In this lesson, you will learn to find roots of real numbers. Now, when we say finding the root of a real number, roots are the opposite of exponents. So for exponents, we learned how to find something like 0 squared, where you take 0 times 0, and that's going to equal 0. 1 squared would be 1 times 1, which would be 1. 2 squared means you take 2 times 2 to get 4. 3 squared is 3 times 3. 4 squared is 4 times 4. 5 squared, 6 squared, 7 squared, etc. So the squared means you're taking whatever number is being squared and multiplying it by itself that number of times. So if you see a 2 up there as your exponent, you are multiplying that number by itself 2 times. Now a root is the opposite of raising something to a power. So the square root of 0, you ask yourself, what squared gives you 0? And the answer would be 0. So 0 squared equals 0, so the answer for the square root of 0 would be 0. Square root of 1 is asking what squared gives you 1? And the answer is going to be 1, because 1 squared gives you 1. The square root of 4 is asking what squared gives you 4. And we see that 2 squared gives you 4, so the answer is going to be 2. So notice the answer for these last three, 0, 1, and 2, have been what we've been squaring, 0, 1, and 2. If we take the square root of 9, we ask ourselves what squared gives you 9? And the answer is going to be 3. 3 squared gives you the 9. So we can keep going. Square root of 16 is asking what squared gives you 16. That's going to be 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7, and etc. Okay, so the square root is asking what squared gives you that answer. Now we can expand that principle to any exponent. So if you raise all of these numbers to the third power, what we are doing is we are multiplying that number by itself 3 times. So for the first one, 0 cubed means 0 times 0 times 0, which would just be 0. 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is you're multiplying 2 by itself 3 times, so 2 times 2 times 2, which gives me 8. 3 cubed means you're multiplying 3 by itself 3 times, so 3 times 3 times 3, which is 27. And notice you can keep going for any size of number, and you're going to multiply whatever number that's being cubed by itself 3 times. Now to find the root of this, which is the opposite of raising something to the third power, we can take the cube root, which means what cubed gives you that number. So the cube root of 0 is asking what cubed gives you 0. And the answer, well, it was 0. 0 cubed gives you 0. So that is my solution. The cube root of 1 is asking what cubed gives you 1. And that's going to be 1. Because 1 cubed gives you 1. The cube root of 1 is going to be 1. Then you have the cube root of 8 is asking what cubed gives you 8. Well, 2 cubed gives you 8, so your answer is 2. We can keep going. Cube root of 27 is asking what cubed gives you 27. And it's going to be 3, because 3 cubed gives you 27. So if we do that for each of these, the cube root of 64, 125, 216, and 343 would be 4, 5, 6, and 7 respectively. So when you see the cube root like that, you're asking what cubed gives you the number inside of the radical. And then we can expand this even further, so the exponent is not just 2 or a 3, but it could be to the 4th power. So here, 0 to the 4th power means 0 multiplied by itself 4 times. So 0 multiplied 4 times gives me 0. If we have 1 to the 4th power, it means 1 multiplied by itself 4 times. So 1 times 1 times 1 times 1 gives me 1. 2 to the 4th power is 2 multiplied by itself 4 times. So 2 times 2 times 2 times 2 gives you 16. 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. 4 to the fourth is 256. 5 to the fourth is 625, and etc. So then we can take the root of a number and see what to the fourth power gives you a particular number. So for example, the fourth root of 0 is asking what to the fourth power gives me 0. And the answer is going to be 0, right? Because 0 to the fourth power gives me 0. And then we can keep going and say the fourth root of 1 is asking what to the fourth power gives me 1. And that's going to be 1, right? 1 to the fourth power gives me 1. Keep going, the fourth root of 16 is asking what to the fourth power gives me 16. And we see that 2 to the fourth power gives me 16. So my solution is going to be 2. Fourth root of 81 is asking what to the fourth power gives me 81. And here we see it's a 3. 3 to the fourth power is 81. The fourth root of 256 would be the 4, and the fourth root of 625 would be 5. So how we say this, and I've been using this terminology as I've gone along, but just to explain formally, if you see this notation right here, this is an assumed, 2 here, and we say that's a square root. If it's not written there, it's a square root, which means what squared gives you something. Over here, this is going to be the cube root, okay? And so we say the cube root of 0. Okay, and that goes along with the cubing of a number, 0 cubed, 1 cubed, etc. And then over here, there's no specific name that we give to this, but if we were taking the 4 here, we call this the fourth root. Okay, so over here, this is the fourth root. If it was a 5 right there, it's a fifth root, and etc. Now in the next slide, I'm going to show you that the same principle applies even with negative numbers. So, like we said, 0 squared is 0, but negative 1 squared, you take negative 1 times negative 1, which becomes a positive 1. So the answer for negative 1 squared is 1. Negative 2 squared is negative 2 times negative 2, which becomes a positive 4. Negative 3 squared is a positive 9. Negative 4 squared is 16, and etc. So even though there's a negative in there, because you're squaring it, it's going to become a positive number. Okay, so when you're taking the square root, we can take the square root of 1, and that could also equal negative 1, because the square root means what squared gives you 1. Well, we said 1 in the previous slide. 1 squared gives you 1, but it could also be a negative 1, because we see here negative 1 squared also gives you 1. So the square root of 1 could be a 1, or it could be a negative 1. Both are possible solutions. So the square root of 4 could also be a negative 2. The square root of 9 could also be negative 3. And you could keep going for each of these. And the square root could also be the negative number. Okay, and then with the cubing, so 0 cubed would still be 0. But then negative 1 cubed would be negative 1 times negative 1, which becomes a positive 1. And then multiply one more time by another negative. So 1 times negative 1 would give you a negative 1. So when you see the the exponent up here, if that's an odd number, we have a negative times a negative times a negative. The two negatives at the beginning make a positive, but then positive times a negative will always make your final answer to be a negative number. So negative 2 to the third power would be negative 2 times negative 2 times negative 2, which becomes a negative 8. Negative 3 cubed would be negative 27, and etc. So if you see the exponent is an odd number, this is going to be a negative answer. And then as far as the root, if we take the cube root of negative 1, we're asking what cubed gives you negative 1. Well, we see over here, negative 1 cubed gives you negative 1, so my solution is a negative 1. The cube root of negative 8 would be negative 2. The cube root of negative 27 is negative 3, And you can keep going for each of these, and we see our solution will be -4, -5, -6, and -7, respectively. And then with the fourth power, -1 to the fourth power would be negative times a negative, which becomes a positive, times another negative, times another negative, which would become another positive. So your solution, if your exponent is a even number, so here's a 4, and back here was a 2. If your exponent is even, then you're going to have a positive solution. -2 to the fourth power is -2 times -2 times -2 times -2, so 4 times. That's going to give me 16. -3 to the fourth is 81. -4 to the fourth is 256. And -5 to the fourth is 625. So then we can take the fourth root of these numbers, and the fourth root of 1 could also be -1, right? Because -1 to the fourth power would give you 1. So my solution would be -1, or it could be 1, as we discussed in the previous slide. The fourth root of 16 is asking what to the fourth power is 16. Well, we see here -2 to the fourth is 16. So my answer here could be a 2, or as we see here, it could be a -2. And for each of these, we see our answer could be the -3, -4, -5. So make sure you know how to find the roots, whether it be a square root, a cube root, fourth root, etc. So that's the concept behind roots. Roots are the opposite of exponents. Now we're going to look at the same numbers again, but I want to point out another concept that is going to help you later in this chapter. So the concept is, if you're looking at the same numbers, so 0 squared, 1 squared, 2 squared, etc., and instead of writing it, just as a 0, square root of 0, if we keep the squared there, so like the square root of 0 squared, and we're trying to figure out what is that equal to, well, the concept I want to point out is the fact that if you have something squared in the radical, then the square and the square root undo each other. Those are inverse operations. Just like if you started with a number and then you add, say, 3 and then subtracted 3, you're right back to where you started. They cancel each other. And same thing with multiplication and division. If you multiply something by 3 and then divide something by 3, you're right back to where you started. So multiplying and dividing are inverse operations as well. Same thing with squaring and square rooting. The square and the square root will cancel each other out. So if I see something like this, where I have a square and a square root, I can basically just get rid of both the square and the square root, and my solution would just be the 0 on the inside. Let's look at the other problems. Here we have, instead of writing just the 1, we have 1 squared. And if we cancel the square and the square root, notice my answer is going to be 1, just like it is right there. And we keep going for each of these. Square root of 2 squared. So instead of writing a 4 here, we write 2 squared. It's the same thing. And I can cancel the square and the square root. They will undo each other, and my solution is going to be 2. For each of these, if you notice, you can cancel the square and the square root, and you're left with your number, your solution. Cancel this, you're left with a 4. Cancel right here, you're left with a 5, and etc. And that also works with cubes, where if I use the same set of numbers that I had before, and I take the cube root of something cubed, cubing and cube rooting are the inverse operations. So if you see a 3 right there and a 3 right here, you can cancel those out, and my solution would be right there, the 0. Same for any of these in this example. The 3 here and the 3 over there will cancel. I'm left with a 1, which is my solution. Right here, 2 cubed is the same thing as 8. I can cancel the cube and the cube root. I'm left with my number, my solution. For each of these, the cube and the cube root will cancel. I'm left with a 3. Here I'm left with a 4, 5, and etc. And this works for fourth power and any power if the number right here, the exponent, and then this number over here match. those are inverse operations. I could cancel those out. Same thing here. Fourth power and the fourth root. I'm left with my answer. Fourth power, fourth root will cancel. I'm left with my answer. So for each of these, I can cancel the fourth power and the fourth root to get my solution. And that works for any exponent and for any number on the side, where if it's matching, then they will cancel each other out. And I'm not going to explain this in as much detail, but it also works with negatives. So looking at the same set of numbers, if you have a -1 squared inside of the radical, the square and the square root cancel, I'm left with my answer. Squared and the square root, left with my answer. And that goes for any of these, whether it be a square, square root, cube root, or fourth root. Okay, it's going to work for any of these. I'll show you just one over here. The cube and the cube root will cancel. I'm left with my answer of -4. Over here, the 4 and the fourth root will cancel. I'm left with a -4. So it works for even negative numbers as long as the exponent and the number outside the radical are matching. Now, instead of saying, the part underneath the radical or, the number outside the radical, there are names that we can give to these different parts. And so make sure you know these different terms because they will be used throughout this course. Where looking at the three parts, we have the number outside, we have the sign itself, and then we have the number inside the radical. So the part inside the radical is called the radicand. This is a radical sign, and then this number right here on the outside is called your index. So make sure you have those parts memorized. And the main terms that I'll be using is going to be index and radical sign. I don't usually use the word radicand too much, but do be aware of that term as well. Now we discussed that if you take a square root, there's a positive or a negative answer, because a square root means what squared gives you that number. So for the square root of 1, we're asking what squared gives you 1. Well, 1 squared would give you 1, right, because 1 times 1. But it could also be -1 squared, because -1 times -1 would still be a positive 1. Same thing with the square root of 4. It could be a positive 2 or a -2 as the square root. Square root of 9 could be a 3 or a -3. Now when dealing with radicals, we are typically concerned with the positive answer, and we call that the principal root. So the principal root is the positive solution to the root. So for example, the 1, 2, and 3 would be the principal root. -1, -2, -3 would not be the principal root. Now if you have the square root of a -1, this one is kind of a trick question because there really is nothing squared that will give you a -1. Right? If you take a 1 squared equals positive 1. -1 squared would still be a positive 1. So the square root of -1, we call that a not real number. Or another term we'll discuss later, we can name this as imaginary number, because there's nothing that will give me a -1 when I take the square root. Square root of -4 would also be not real, because there's nothing squared that will give you a -4. And also the square root of -9 would still not be real, because there's nothing squared that can give me a -9. Now if the negative's on the outside, however, this will be okay, because the negative, you do that after you take the square root. So basically it's order of operations, right? Order of operations is parentheses first, and then exponents, then multiply, divide, then you add and subtract. The radicals, and we'll explain in a later lesson, radicals are basically the same thing as exponents. So when it comes to order of operations, you treat radicals as an exponent. So you do the exponent or radical first, and then you do the negative after. So the square root of 9 is going to be a 3, and remember, we're concerned with the principal root. So the square root of 9 is going to be 3. then make it into a negative after the fact, so that would be a negative 3. The square root of negative square root of 4, you have the negative times the square root of 4, and the square root of 4 is 2. So we have negative 2 as my solution. Now up here, notice instead of a square root of negative 1, we have a cube root of negative 1. While the cube root of a negative 1 would actually have a solution, because we're asking ourselves what cubed gives you negative 1. Well, that's going to be negative 1, because if we take negative 1 cubed, that's going to give me negative 1 times negative 1 times negative 1, which would be negative 1. So the cube root of negative 1 would actually have a solution because we take a negative 1 cubed to get negative 1. Same thing with cube root of negative 8. We're asking what cubed gives you negative 8. Well, if we take negative 2 and we raise that to the third power, that would be negative 2 times negative 2, which is a positive 4, times another negative gives you a negative 8. So my solution would be negative 2, because negative 2 cubed gives you negative 8. Now the question is, what about a fourth root or some other root of a negative number? Well, the fourth root, we're asking what to the fourth power equals negative 1. Well, if we try a negative 1 to the fourth power, we would have 4 negatives, 1, 2, 3, 4, which would become, say, 2 negatives make a positive, 2 more make a positive. So even negative 1 to the fourth power would not give me a negative 1 back out. So because of that, there's nothing to the fourth power that gives me a negative 1, so this one would be not real. And the fourth root of any negative number, whether it be 16, 1, or whatever, would always be not real. So the concept is this. If you have the square root, which is an assumed index of 2, okay, so if it's a square root of a negative number, it will not be real. If it's a cube root, it will be real and have an actual solution. Fourth root would not be real. Notice how it alternates. If it's an even index, it's like 2, a fourth root, sixth root, eighth root, etc., and there's a negative number underneath, it will not be real. But if it's an odd index, like a 3 or a fifth root or seventh root, then it will have an actual solution. It will be a real number. So now the next part of the lesson will discuss fractions, and then we'll discuss equations at the end. So with fractions, let's say you had a square root of 1/4. Well, the question is asking what squared gives you 1/4. And you can maybe think of this in your head as being 1/2. But if you don't see that, what you can do is you can take the square root, or whatever root we're dealing with, of the numerator and the denominator. So we could take the square root of 1 and the square root of 4 and do those separately. So the square root of 1 we know to be 1. The square root of 4 is 2. So my solution is going to be 1 over 2. So let's say you had the square root of 4 over 9. You can break it apart to be the square root of 4 over the square root of 9, which would give me 2 over 3. And the square root of 9 over 25, you can break apart to be the square root of 9 over the square root of 25. And the square root of 9 would be 3. The square root of 25 would be 5. So my solution is 3/5. So that's how you can deal with fractions. You can break it apart and then do each part separately. Now, as far as equations are concerned, let's say you had x squared equals 25. There's actually two ways to solve this, but I'm going to show you how to use the principle that we learned in this lesson to solve this equation. Now, with any equation, the objective is to solve for x. So what we need to do is get rid of anything that is with the x that should not be there. So in this case, the 2, the square, is with the x, so I need to get rid of the squared. Well, as we stated previously in the lesson, squaring and square rooting are inverse operations. So what I can do to get rid of the square is I can take the square root of x squared. So if I take the square root of x squared and the square root of the other side, the square and the square root will cancel. I'm left with an x. And the square root of 25 would just be 5. Or, don't forget though, we have a negative component. It could also be a negative 5. So primarily only when you're dealing with equations are we concerned with both roots and not just the principal root. Because if you plug 5 or negative 5 back in, 5 squared would be 25, or negative 5 squared would also be 25. Here we have x cubed equals 8, so the exponent is different, but the concept is still the same. To get x by itself, I need to do the opposite of cubing, which would be the cube root. So I can take the cube root of both sides, and when I cube root the cube, that will cancel each other, and I'm left with an x on the left side, and the cube root of 8 is asking what cubed gives you 8. And the answer is going to be 2, because 2 times 2 times 2 would give me 8. Now you might be thinking, why is it not 2 or negative 2 like it was for the first example? Well, think through the difference with a cube, where if it was negative 2, that means negative 2 to the third power would be 8. But it's not. If we take negative 2 times negative 2 times negative 2, that would become a negative 8. So that is why my solution is not negative 2, but only positive 2. Now let's look at this next example, and I'm going to show you now 2 ways that you can solve. So the first method is by factoring, which is what we've done on the previous chapter, where you see that this is a difference of squares, and I can factor as x minus 6 times x plus 6. And then now that you have the 2 parts being multiplied together, using the zero product property, I can set each part equal to 0. So either x minus 6 is 0 or x plus 6 is 0. So then x would have to be 6 or negative 6. That's one way we can solve, but then now using the method learned in this section, you could also take the square root of both sides, where what I can do is I can isolate the x squared by adding 36 to both sides. And then when I do that, I now will have x squared equals 36. And from here, I can take the square root of both sides, and the square root will cancel. I'm left with an x on the left side, and the square root of 36 could be either a positive 6 or a negative 6. So either method works, and it doesn't matter which method you use as long as you get the correct solution. But make sure you realize you can use either method, because there are cases when one method might be better than the other. So here's one of those situations where one method is better than the other. And in this scenario, you actually cannot factor this. It looks like you can, but you cannot, because it's not a difference of squares. This is a plus sign. So what I want to do is I want to get x by itself. I can try to isolate that squared term by subtracting 49. And when I do that, I have x squared equals negative 49, which allows me to then get rid of the squared by taking the square root of both sides. When I take the square root of x squared, this becomes an x, and the right side would be the square root of negative 49. But notice you have a square root of a negative number. And at this point, we have just left it as the fact that this will be considered as not real. So your solution at this point would be not real, or no real solution. Here's another example. Here we have 16x squared minus 25 equals 0. I'm going to show you both methods and allow you to pick whichever one is easier for you to use. This, with method 1, we can see that this would be a perfect, or a difference of squares, where I can think of this first term as 4x squared, and the second term would be a 5 squared. So I can factor this as a difference of squares, where I have 4x minus 5 times 4x plus 5. And then from here I can set each part equal to 0, where either 4x minus 5 equals 0 or 4x plus 5 equals 0. And then I can solve this for x by adding 5 to both sides for the first equation. Second equation, I subtract 5 from both sides. And when I do that, first equation, I have 4x equals 5. Second equation, I have 4x equals negative 5. I can solve for x by dividing both sides by 4. Do that for both equations. So now I have x equals 5/4 or negative 5/4. So that is method 1. Method 2 is using the principles learned in this lesson, where given the same equation, I can isolate the x squared term. So to isolate, I can bring the 25 to the right by adding 25 to both sides, which leaves me with 16x squared equals 25. And then from here, I can then take the square root. When I take the square root of 16x squared, the square root of 16 is 4. The square root of x squared would just be x. Or I can think of 16 as 16x squared as 4x squared. Either way, I get 4x back out. So I get 4x equals the square root of 25, which is either 5 or negative 5. So then, solve for x. I can divide both sides by 4. And I will get x equals 5/4 or x equals negative 5/4. Just please be careful if you do use method 2. Make sure that you account for the positive and negative part for my solution, because that is probably one of the most often made mistakes with this lesson and with equations specifically, is not accounting for the positive and the negative component. And that concludes our lesson for today, and we will see you next time.